Section 10.3, define and use probability. The probability of an event is a number from 0 to 1 that indicates the likelihood the event will occur. Probabilities can be written as fractions, decimals, or percents. The theoretical probability of an event. When all outcomes are equally likely, the theoretical probability that an event A will occur is the probability of A equals the number of outcomes in A over the total number of outcomes. The theoretical probability of an event is often just simply called the probability of an event. So looking at an example of a theoretical probability, or just a probability, you pick a card from a standard deck of 52 playing cards. We're going to find the probability of picking an 8, and then we're going to find the probability of picking a red king. So we want to know probability of picking an 8. So we want to know the number of 8s in a deck of 52 cards. There are going to be 4 8s, one of each color, hearts, diamonds, clubs, and spades. Out of 52, that's your total possible number of outcomes, because there's 52 cards in the deck. And then we can reduce 4 over 52 to 1 over 13. The probability of picking a red king, we have probability red king. So in a deck of 52 playing cards, there are 4 kings in the deck. 2 of them are red and 2 of them are black. So we have 2 red kings out of 52 playing cards, which we can reduce to 1 over 26. So using permutations or combinations. So if a cereal company plans to put 5 new cereals on the market, a wheat cereal, rice cereal, corn cereal, oat cereal, and multigrain cereal, the order in which the cereals are introduced will be randomly selected. Each cereal will have a different price. So we want to know what's the probability that the cereals are introduced in the order of their selected retail price. So this is using permutations and combinations. We want to know how many different possibilities there are for the order they can be introduced. Well, since there's 5 new cereals, the order they can be introduced, there's going to be 5 factorial ways that they can be introduced. And 5 factorial is 120. 5 times 4 times 3 times 2 times 1. So in the order of selected retail price, there's one way that they can be arranged in that order. That is one of the 5 factorial orders. So our probability that's going to be chosen is 1 out of the 120 different ways that they can be ordered. And then we can get a decimal approximation, which is 0.0083. What is the probability that the first cereal introduced will be the multigrain cereal? So there's 5 different cereals. That could be the first one. Multigrain cereal is 1 of those 5. So the probability it could be multigrain is 1 out of the 5 different cereals that there are. So another thing we can use is odds. And we can use that to measure the likelihood an event will occur. Odds measure the chances in favor of an event occurring or the chances against an event occurring. And they are different from probability. So to find the odds in favor of event A, you're going to have the number of outcomes in A over the number of outcomes not in A. And then the odds against event A is going to be just the opposite of that. The number of outcomes not in A over the number of outcomes in A. So you can write the odds in favor of or against an event in the form A over B or A to B. So finding odds. So we want to, if we roll a standard six-sided die, we want to know the odds in favor of rolling a 6. So we want to know the number of outcomes in A. So the number of outcomes of rolling a 6. Well, we have 1. And the number of outcomes of not rolling a 6, there's 5 of those. Because there's only 6 numbers on a die. One of them is a 6 and 5 of them are not. So your odds in favor of rolling a 6 are 1 to 5. Or you could write it that way. And then we want to find the odds against rolling an odd number. So we want to find the number of outcomes not in A. So the number of outcomes that aren't an odd number on a six-sided die. That would be 3, 2, 4, and 6. And then over the number of outcomes in A. So the number of odd numbers on that die, which there's 3. So 3 over 3, which we could say is 1 to 1. Okay, and then finally we're going to look at, experimental probability of an event. So experimental probability is when an experiment's performed, it has a number of trials, and you find the probability. It's not necessarily going to be the same as a theoretical probability. Because experimental is going to be based on what you did in your experiment, and what the number of trials where A occurs over the total number of trials. So finding an experimental probability. So the blood types for a sample of donors at a blood drive are displayed in the table, which I'm going to have up here for you. And we're going to find the experimental probability that a randomly selected blood donor would have type O. Okay, so type O, we have 22 donors. So that's the total number of trials where A occurs was 22. And then we're going to figure out how many total trials we had by adding these up. 22 plus 21 plus 5 plus 7. So 22 plus 21 is 43. Plus 5 is 48. Plus 2 is 50. So there's 50 total trials. 22 of them were type O. So 22 out of 50, and we can reduce that to 11 over 25. And then we can also say that equals 0.44, or it equals 44%. And the last topic in this section is on geometric probability. So some probabilities are found by calculating a ratio of two lengths, areas, or volumes, and then those are geometric probabilities. Okay, so then find the probability that a dart thrown at the rectangular board hits one of the triangles. Assume that the dart is equally likely to hit any point inside the board. So what we're going to do here is we're going to find the probability that we land into each of these. So we're going to calculate the area, the area, the area, add them together, and then it's going to be out of the whole dartboard. So the area of the whole dartboard is 10 times 40. It's the area of the whole rectangular region. The area of each of these triangles we're going to calculate, add them together. So the area of a triangle is 1/2 base times height. So 1/2 times 4 times 3. 1/2 times 8 times 5. And then 1/2 times 3 times 4. 4 times 4 times 4, 3. And that's going to be what our probability is. So 1/2 times 4 times 3 is 6, because 1/2 of 12. 8 times 5 is 40, half of that is 20. And this is half of 12, which is 6. And then 10 times 40 is 400. So then 20 plus 6 plus 6 is 32. And then we can reduce that to 8 over 100, which is 8%. You could go further and leave it as a fraction, or you could put it as a decimal, which would be 0.08. Any of those would work, but that's your probability that it's going to land inside one of the triangles.